So yeah, thanks for coming. My name is Preston Smith. I'm the Director of Research Computing Services at Purdue University. I'm going to talk about our research data services that we provide at Purdue that are built on DDN solutions. So at Purdue, our researchers have had 150 years now of taking giant leaps. Our researchers use our community cluster program for doing their high performance computing. I want to talk about that real briefly, just to lay some context as to how our data services fit into this. So as an example, aerospace is a big sector at Purdue for research. The cradle of astronauts. I think we've got 23 astronauts that have come out of Purdue University, and research in aerospace is one of our biggest consumers of high-performance computing. This is an example of one of the separation unsteadiness that happens in designing airframes and engines. So our community cluster program is the foundation of our campus cyber infrastructure. The basic rules, we build a cluster every year. Faculty members invest their grant or startup money into the program. And since 2008, we have several $1 million of investment into this program every year with faculty members' own grants. The general idea is that you get out what you pay in. Whether you buy one node or 100, you get what feels to you like a private resource. But there's more. You get to use everybody else's idle cycles when they're not using them. So you have a great opportunity to get out more than you put in. But the best part, as a university faculty member, you don't have to do the work. Your graduate student doesn't have to admin computers. You don't have to worry about your computer getting hacked. You let the professional staff in the supercomputing center admin and support your systems. So we've been able to build a number of world-class systems during this program, with one as high as number 28 in the world several years ago, Conti. It's actually still on the list here in 2018. So our partners have come from every corner of the university, certainly heavily represented in physical sciences and engineering, but all the way down into agriculture and humanities as well. So we have researchers from 50 departments in every academic college at the university. Dr. Matt Huber is another person that uses our high-performance computing systems, and as a global climate modeler, you can imagine that high-end, reliable, high-performance storage is very critical to his ability to do his research. So, about cluster storage. So in the early years of our program, we built relatively large systems. Our first couple of systems were nearly 2,000 nodes in some situations, and we found, believe it or not, that the storage on those systems was less robust than it was today. Lots of NFS servers, which was great for some of our small clusters, but as you can imagine, a 2,000 node cluster off of an NFS server did not work that great. Our very first DDN system, looking back and preparing these slides, back in 2005, we had an S2A 8500 running Ibrix. So bonus points to anybody here who remembers Ibrix. Alex and Pat remember it. All right. Now, we wound up in about 2009, we had a Gaussian-induced crisis caused on our NFS clusters to force us to look at something more capable. So since 2001, we built a parallel file system-based scratch system on every cluster. So you can see once upon a time we had small quotas, small file systems on our NFS. But then starting in 2011 with our Hansen cluster, and then on the Carter and Conte, we started getting a multi-petabyte Lustre file systems. All the way up to today, when we just built our flagship Brown supercomputer last year with a 3 petabyte DDN 14K based Lustre, with every user getting access to a 200 terabyte quota. So you can imagine Dr. Matt Huber doing his global climate modelers is a lot happier with our DDN Lustre based scratch file system than that NFS server in 2008. So in a more general sense about research data at Purdue, everybody's doing something that's data intensive. Dr. Michael Rossman here is from our structural biology group. He does cryo-EM microscopy, so if many of you on your own campuses probably see people doing cryo-EM. It's very data intensive. They can generate tens of terabytes in a day. They use the high-performance computing systems in the data storage to simulate the Zika virus at high resolution. So if you're on a campus, you can see researchers. They have a problem, and they're going to find a solution for it one way or the other. So we see researchers coming up with their own systems at the very low end. Things like this, building their own networking solutions here. Like I'm sure the Mellanox guys would love to see that network hub out there over here, and people just rolling their own data storage. Everybody knows that data storage is growing. Our tape archive has shown exponential growth like this, 14 years to hit a petabyte, 14 months for the second, 9 months for the third, and on and on and on. I think it's actually up over 13 or 14 petabytes in the archive now. So in storage for HPC, we saw a gap in 2013. Many storage offers at the universities are not up to the task of HPC. We can't use the enterprise systems because we would break them and then they would break us. It's just not a good match. Researchers had a number of common requests that our Scratch systems couldn't do and the tape archive couldn't necessarily do. And over 20% of our support tickets from our researchers involved working with their data, usually articulating a gap. Nowadays, it's 25% of our support requests comes in about data, so I think that's better. But the tone of the questions have changed. They're asking for how do I do these sort of things, rather than saying that there's no way for me to solve these problems. So we came up with our solution called the Research Data Depot in 2013. This is a DDN-based system here. It's built with 12Ks, I believe, one in completely different data centers across campus, actively written within GPFS, so a researcher can write a file, it's replicated to 2 data centers, and there's a disaster recovery copy that's done periodically as well. This has been a great hit. It's for the researchers. It's a scalable system. It's built on the high performance DDN hardware using GPFS, which is very, very scalable. It's a regular POSIX file system. They don't have to worry about object stores or anything that they don't mentally relate to. And it's aimed at the individual PI, not like an individual person. The PI just thinks of their world as the research lab, and everything else falls out around that. So we organize the spaces around common data management patterns for researchers. They oftentimes want to share applications, have common sets of data, maybe host a website, a version control repository, directories for their users that the PI still has access to. And it's been very impactful. In just 4 years of service, we've taken on 550 research labs as partners in this storage system. To give you an idea, in 12 years we only have had 220 cluster partners. So data storage is a very fundamental thing for our research. 60% of these people are not HPC users. So when we built something at HPC scale to be able to use on our supercomputing systems, we found that all of these researchers from around campus, from these domains that we don't talk to, from health sciences, from the humanities, from the School of Management, all have the same data management use cases that our HPC researchers do. So we've sold over 2 petabytes of a 2.25 petabyte file system since 2014. Which brings us to a great problem. We are running out of space. We have sold all of it to our researchers. They're very happy with our DDN-based storage offering. So we are currently in the procurement process of a 5 petabyte expansion to the Research Data Depot. So this one is going to be based on the 14K platform. Now it'll still have copies, 14K arrays in 2 different data centers. But now with the affordability of the platform, being able to get so much storage for the dollar, now we're going to be able to add a third, completely off-site, replicated copy of the data, managed asynchronously. So we're looking forward to getting that purchase finalized, working with our DDN support staff and getting that integrated, and get that system upgraded and provided to our researchers.